Hello everybody and welcome back. So let's continue. We want to improve the sparks motion now, and what I'm looking for to add is different motion, different behavior based on the life of the sparks, because I'm mainly interested in getting something very turbulent towards the end. Maybe we can calm it in the beginning of its lifetime when it gets emitted, and or maybe in the center, or maybe we randomize it. I just want to have first access to that control. So what I'm gonna do is I'm gonna copy a pop color node from my current setup. I'm gonna paste it here, and what this is gonna, it's just a ramp, and right now this ramp is looking for the normalized h, and the nh is a value that goes between 0 to 1 based on the lifetime of the particle. And I wanted to visualize this so we can clearly see it, but what I want is I'm gonna disable it, copy it, and let me disable this so it's faster. Let me disable the collision and also lower the number of points. That's fine. Okay, so let's go back inside, and I'm gonna get the second color here, and instead of orange I'm gonna change it to red, and everything else is going to be black like this. So if we hit play, we're gonna see it. That's its life. Okay, sorry, it's the other way. So something like this, and then if I hit play now, we will see particles as they get closer to dying, they have this red color. Okay, so everything that is close to dying, they will get this red tint. And let's change it to white. And the idea is I want to use this as a multiplier on top of the force. So let's create a pop force, and let's set this to, let's say, a value of 10 and a swirl size of 2. And inside the, I'm going to turn on use vex expression, and I'm going to say pass through or amplitude by h. Perfect. This is the expression we want. So this is going to change the amplitude based on the particle h. I don't want the h, I want the normalized h. Okay, and the range is going to be between 0 and 1, and I'm going to negate 0.2, so I shift all the range to only affect 20% of the particles. If you wanted to affect more of the particles, you can shift this range backward. This is very similar to the ramp that we did here. This is maybe using 5%, and with this trick I don't have to create any graph. I know it's going to affect that amount of particles. So if we go back, let me disable the color, and let's turn this on. If we hit play, we're going to see the particles moving in an erratic way as they get closer to dying. It's not very visible. Let's try again. Let's put this one to no, let's put it to 1,000. That's too much. So let's put 100. And if we hit play, you will see it. See it there. Now the amplitude, the swirl size is quite big, so I'm gonna lower it to 0.4. And see, as they get closer to dying, they get picked up by this force. And let's lower it to 10, and maybe only 10%. 10% of its lifetime is when it gets affected towards the end. Before it dies, maybe half, a quarter, 10% of its lifetime. And you can see the effect here. And this behavior is very, very crucial to the sparks. And what we can do is we can layer a couple of them. And I'm going to copy the existing network which I have previously used, and it's very simple. So it's affecting 20%, and the amplitude is different because the scale is different, so it's not going to be exactly the same. So I'll go with 10 with 5 here. I'll go with 4 here, and I'll go with, this is only for gravity. So particles that are going to, the particles get more and more gravity as they get older. And here between, instead of 0 to 1, I'm padding that range so it's not narrow. It's just softening it so that all the particles are getting affected by the gravity, and the older it gets, the more gravity it's going to be applied to it. So if we hit play, we should see, yeah, we see some nice movements there, some nice movements here, and some of them are falling as they get older. Maybe we need to increase the gravity, but this is the main idea for controlling, getting that nice motion. The trick is to get them to swirl as they get older. Obviously we still have to tweak this, but I think for the purpose of explaining, this is plenty. So the next thing we want is we want to have an orient attribute that we can use to rotate the particles over time. So they start with one orientation, and then as they move faster or they get older, they twist faster and faster. So what we need is we need an orient attribute to be set. So I'm going to copy an existing attribute, randomize, and we have to call it orient. It's a quaternion, so the dimension is 4 and the angle is 180, and this just gives it a random starting point. That's all. This is a random vector, random orient attribute per frame, and we can visualize it here. If we click now, we're getting this matrix on each point, and if I move it, we're not going to see it rotate because there is no torque applied in the sim, and we're going to do that. So the next thing is I'm going to use a pop torque. I'm going to copy an existing one. So for the pop torque, I use the amplitude of 200, amount of 200, and then the amount is driven by the age. So the older it gets, the faster it spins. And if we hit play now, we're not going to see anything here. So let's go up, and where we have this, I'm going to make it even smaller. So as it gets older, it's going to spin more and more and more. And this is going to work plenty, it's going to be enough for the particles. And we're only seeing this weird issue because we're deleting frames, deleting points every frame. And I'm worried about doing it here. So pack an instance, let's see. Let's put down a circle instead. And this is how I'm planning to render them, by the way, as disks. So that when they spin, when they spin, we don't see them, but then they come back. Well, it looks like they came back because of the spinning effect. And then as they get older, they're gonna spin faster and faster. Okay, cool. So the other thing we could do is we can add a mass attribute. So when I showed the previews here, you can see some are bigger, some are too small, some are mid, and we need that randomization. It's very, very important to sell the visual of the sim. And what I'm going to do is I'm going to create a random attribute. So I'm going to paste the expression. It's a number, so float, I just called it number, and it's random based on the point number. If I'm setting the mass, 10% of the points will get a mass of 100. 10% to 40%, basically 30% of the points that are not this are going to get a value of 200, and then everything else is going to get a value of 1. So this means that we have 10% that are very heavy, 30% that are okay, they're not too heavy, they're not too light, and then everything else, which we can also randomize. Maybe here, instead of 1, change it between 0 and 5 to 4 to add more randomization. And this value also I'm going to use later to drive the scale, but for now I'm only using it to drive the mass, and this is going to make it look even more interesting. And let's make sure. So physical properties. Yeah, use mass. We have to make sure that we have a use mass attribute. And the last thing that we need to add is a pop drag. So pop drag, this is always use a pop drag. I'm gonna start with 0.01 or 0.05. And let's go up and hit play. I don't have collision, so it's yeah, I think it's working. I think the turbulence towards the end could be better for sure. Let's see. I don't have the curves. This I don't need. Actually, I will use this just to add global randomization overall. And then that, and let's go back up. And let's hit play. You see here, you see they're moving quite fast. Okay, I think everything is working as expected, and that's all there is for the sparks idea. We need to have an orient attribute because we will need it later. We'll need this a mass attribute so we can use it to drive the p-scale attribute, and that's it. We can increase the number of sub-steps here if we wanted more accuracy in the sim. And then we have this, we have the collision, we have the source. And one last thing I wanted to talk about is if we compare this with this, we will not see that we have enough points where we see the data here. And this is not great because if, let's say, we couldn't manage to move points from this location all the way to fill this gap for whatever reason, it's not going to be, the sparks are not going to match the sim quite well. So what we need to do to make this, to solve this problem, is we need to use a dynamic emitter. And what the idea is to use actual points from this to emit sparks dynamically instead of one frame at a time, or a static frame. So I'm gonna copy one node, and I don't want to emit from everything. Okay, I only want to emit where the sparks are moving quite fast. So I have this point VOB that isolates the based on velocity, and I'm gonna delete everything that is black. So everything that has low amplitude, or sorry, that is not moving too fast, we're going to delete. I think we can go a bit more aggressive with this to maybe 3, too much, 1 and 4. Something like that. Okay, so which means is whenever we have fast moving data, we're going to get particles and sparks emitted. And let's see what we have here. I'm going to delete points I don't want to emit from everything, so something like that. And then the trick to blend these in is to have the particles be black for the first couple of frames. So instead of starting yellow, we can use a black color or fade them so that they don't start with this right away. And let's change this. I'm gonna delete this one, something like that. And let's see how this looks now. So If we hit play, they're going to move, they're going to have something close to them to attract with, and it's going to feel natural as well. So this is the best way to make sure that we always have particles where they need to be. And look, because they're not popping in at once, it's really easy to work with these points now. And trust me, this system here is gonna give you 10 times better sparks compared to using the custom workflow, and it's gonna be really fast to do all of this. Okay, that's it. Thank you guys for watching, and see you in the next video. Bye bye.